So yeah, this is the first chapter of my PhD. It's a review, so I don't have any cool graphs, but oh well. Yeah, so basically, spatial prioritization, it's a method for, basically it's a method for quantitatively identifying, so mapping, spatial priorities for conservation actions. And it's widely used to allocate or to inform decisions about where to allocate conservation resources. And while traditionally spatial prioritization approaches didn't incorporate climate change, over the last 10 or 15 years, a number of approaches that do have emerged. And so I wanted to do a review and summarise those approaches and look at their benefits and weaknesses, and hopefully provide us some sort of guidance to planners who are trying to make decisions about how they can help biodiversity deal with climate change. So I conducted a systematic review of spatial prioritisation literature, looking for approaches which identify spatially some sort of priority for dealing with climate change. It didn't really matter what or how, just that they did it. And for each approach that I found, I assessed whether they considered direct impacts or indirect impacts of climate change. So direct impacts are things caused directly by climate change, things like sea level rise or temperature change, whereas indirect impacts are things caused by humans responding to climate change. So things like shifting agricultural production or shifting fishing effort, stuff like that. I also assessed whether they considered discrete or continuous impacts. So continuous impacts are slow, gradual changes that you normally associate with climate change, things like ocean acidification, sea level rise. And discrete impacts are one-off extreme events, so things like droughts, cyclones, coral bleaching. I also looked at the time frame of prioritisation. Yeah, sorry.
So I think about, well, which way is the impact you're talking about? Is it how a conservation area is considered in response to climate change?
No,
how that conservation is affecting climate change?
How it's considered in response to climate change. Yeah. I looked at the time frame of prioritisation and also the biological units in spatial scale. So what I found is that there's a very low number of approaches which actually deal with climate change or try to. There are over 1,100 spatial prioritisation papers in 2008, so there'll be even more now. And I found only 46 approaches, or 46 papers which deal with climate change, so that's less than 4%. So that's kind of alarmingly low, given the impact that climate change is likely to have on biodiversity. I also found that human responses to climate change and extreme events are ignored. I found one paper which looked at each of those. Again, alarming, especially given that some studies have shown that human responses to climate change may outweigh the direct impacts of climate change. And generally they were done at a large spatial scale, multi-species or ecosystem level. And I'll present one figure from this paper. So this is our figure one, and this just is basically where we analyse the actual strategy that each paper used to help species deal with climate change. So we found 6 core strategies. The red box there. The most common, that in the brackets is the number of papers that use that strategy. So the most common was to prioritise for future distributions of species. So basically they almost every paper just used species distribution models and climate models to predict where species are going to go. Okay, cool. And then prioritise for those areas. Representing refugia was another common approach. So that's basically identifying where climate change is likely to have little effect or change the least. Increasing connectivity between existing habitat is hopefully going to allow species to move and track suitable habitat as the climate changes. Representing heterogeneity is a strategy where you aim to represent a wide range of abiotic or climatic factors and hopefully represent a wide range of biodiversity going forward. And then the bottom 2 approaches were the 2 that incorporated discrete impacts and the human response. So again, that identified priority areas to minimise the probability of catastrophic coral bleaching. And Valera basically predicted how human land use is going to change in the future, using climate change as one of their predictive variables, and then identified priorities for future species distributions while minimising the conflict between those human land uses and species distributions. And so in the paper, we basically go into more detail about each of these broad approaches, what they're good at, what they're bad at, and how they can be improved, and what future research needs there are to improve those strategies. And it was just published earlier this year. So if you are interested in it, send me an email and I can swing the paper your way. And yeah, that's it.
Was this just looking at systematic conservation kind of approaches?
Yeah.
So how did you lot of those papers wouldn't have been, they would have been prioritized based on something else.
Yeah, so it's just, all it was that, all our definition was that just they have to basically map a priority based on some quantitative factor.
So they don't have to account for cost or feasibility
No,
as long
no.
as they're saying, we've done this analysis
Yeah,
and we're identifying
yeah.
the priorities.
But we wouldn't allow just like an expert opinion thing. It'd have to be a quantitative.
Did you review all 1,000? Or?
No, so that 1,000 comes from Kerry Wilson's book. That was in May 2008. That's just a broad number of spatial prioritization papers back then.
Okay.
I didn't actually end up with a number that I found in total because we did it sort of backwards, but yeah. So 46, which incorporate climate change, so it's pretty low.
How many was Mark Sanders' other decisions?
About 3/4 probably. Mark Sanders' donation or one of those, yeah.
Did you notice any kind of patterns in where these studies were focused on, like territorial areas or?
So basically, North America, Europe, and Australia. And mostly terrestrial. So just like the general trends in the general conservation literature, it's basically the same. Yeah.
So you haven't looked at any of the new papers since 2008?
Yeah, I have. Yeah.
Is there an increase in ones that are looking at climate change?
Yeah, a little bit. So sort of, maybe the last 5 years there's been more. I think the first one was 1990 or 2000 and something like that. But yeah, there has been an increase, but still it's such a low number. Yeah. Yeah.
I assume since the vast majority have not investigated the indirect impacts, so human response to climate change, this is under the one where they did. Do you know why? Maybe what they did in their paper, how they used the responses of humans in order to quantify it? That would explain why most other researchers are not.
Yeah, well, I think the general reason that most people don't do it is because it's hard. Predicting how humans are going to change their behaviour due to climate change is kind of difficult. That means working with social scientists, which often doesn't happen. So what they did was they used a model called IMAGE, which predicts land uses basically, and so climate goes into that model, and along with a range of other factors. And they used future climate models to see how climate would change the land use potentially. But other things that you could do is just simply use changes in agricultural suitability. Generally, if land's suitable for agriculture, people are probably going to go there and convert it to agriculture. So that would be one way to do it, which no one did. So there are these sort of simpler methods which could be used and aren't, but it is quite difficult. Yeah.
In your review, did you attempt to assess the extent to which the prioritization goals have been empirically shown to actually be important?
No. That would be very interesting. Yeah, no, we didn't. That is some of the criticism with these things, like does increasing connectivity, the strategy is that it will allow species to track climate change, track suitable habitat, but whether that's actually true or not, is sort of up for debate. So no, we didn't. It's discussed, some of the things for each approach, but we didn't compare it.
Sorry, if it's such a low proportion, if it's such a big missing area of research, is there any obvious low-hanging fruit?
Sorry?
Is there any obvious low-hanging fruit? Is there any particularly easy, if it's all up for grabs because people haven't done it, where are the easiest points to
What should I be doing? Well, I think that agricultural suitability thing that I mentioned before, that's something I'm going to explore in my PhD. Using cumulative threat mapping, so looking at how human threats to the environment are going to change with agricultural suitability changes under climate change. I'm working with Oscar Venter, who's just sort of updating a human threat map for the globe, and he's found, I think, 92% of the variation in that threat map is explained by agricultural suitability. So I'm going to use future agricultural suitability, some sort of models of that to look at where it's probably going to be converted to agriculture in the future. So that's one. And then, yeah. Yeah.
Thank you.
I was just going to say, if you're thinking about where else you could go from there, were you interested in focusing on that human response to climate change, or are you just saying that it's something that has not at all been considered? Because I know a lot of there
Yeah,
really
yeah.
interesting to consider about what adaptation plans are actually in works at a government scale
Yeah.
or at local scales. Like, are they in the process of building seawalls?
Mm. Yeah, we discussed that in the paper. I haven't actually looked at them, but using sort of government plans, like I know Kenya has a Vision 2030, which is like their plan for expanding agriculture and dealing with climate change and those sorts of things. So those can also be used to help inform decisions.
Thank you.